Hello, everyone. We'll be investigating how to solve a relatively interesting physics problem in a very interesting method. So I'm going to draw it out as such. So essentially, what we have is a rope. We have a given rope. And this is not the rope, this is the ground which is on. And this rope has constant density. And so we have our rope, and this looks like this. Entirety has a length of L, its entire mass is M. And what we want to do is figure out some function that determines its position with respect to time. So what could this function be? So it's going to be hard to figure. This is not actually that hard to figure out. We're going to see why. So let's look at this entirely. What forces are acting upon this? The only thing is gravity. But what part of gravity? It's the gravity the force of gravity acting upon the part of the rope that's hanging. So let's have that hanging part be represented as x. And this is sort of its position with respect to time. And so what we're going to have is this. We're going to look at this. So we obviously know because of Newton's second law that force equals mass times acceleration. And so the force here is the force of gravity. So this is going to equal mg. But what exactly is what exactly is the mass here? So the entire the entire rope is a mass of m, and so it has uniform density. So it's just the portion. It's just going to be equal to the entire mass of the rope multiplied by x over L, which is the portion that's hanging off. So that's simple enough. And this is equal to MA. This is equal to MA. And A exactly is what? It is acceleration, which is the rate of change of velocity, which is the rate of change of position. So acceleration is just the second derivative of the position. So this is how we're having it here. This is what we're going to look at with respect to time. So now we have a little differential equation. Let's rearrange this. Let's divide both sides by m. And what we get is the second derivative the position x with respect to time is going to be equal to xg over L. And so this is going to be, we can just rearrange this and we get the second derivative of x with respect to time minus xgl is equal to 0. So what's going to happen here? If you guys are familiar with differential equations, the solution of x is going to be the following. So we have c1 times e to the square e times t to the square root g over L plus c2 times e to the minus t square root of g over L. So that's what it's going to look like. And so the thing is, we have two constants, and the value of x is going to be determined on what is the initial position, and at t equals 0, what is the initial position, but also what is its velocity. So let's just say that, at t equals 0, positions x naught, velocity is v naught. And so now we're going to get an expression for x. So, at t equals 0, the exponential is just going to equal 1. And so we get x naught equals c1 plus c2, which is not too bad. But for velocity, it's going to be a little bit more difficult. So that's just the first derivative. And so you get Square root of GL. My apologies, not looking too nice, but whatever. C1 minus square root of G over L C2. So my God. Okay, so we're going to let's see. We take the equation for x naught. We're gonna multiply everything by square root of GL. So we get square root of G over L x naught equals square root of G over L C1 plus square root of G over L C2. So we're going to get that. So now what we're going to do is we add both these equations. So this equation 2, add it to equation 3. And what we're going to is V naught plus square root of G over L x naught. We're going to get that it's equal to 2 times the square root of G over L times C1. And so we get that C1, just dividing both sides by 2 square root of GL is V naught over 2 root L over G plus X naught over 2. So I don't think it's too difficult to verify. But that's what you get for C1. For C2, let's just okay, sorry. Anyway, for C2, you can do a similar process, and its value is going to be root V over L x naught minus, or sorry, yeah, no, that's correct. Minus V naught over 2 times the square root of G over L. And this is just basically just an outline of how you get the solution for this. This is how you do it using Newtonian mechanics. You can also do it using Lagrangian mechanics, but that's just a little bit more complicated. But anyway, this is it, and I certainly hope that this video was of use to you. Thank you very much for watching. I'll see you later.